Hello, everyone. I am super excited to be here today and to talk to you about edge caching GraphQL APIs. My name is Max Stoiber. I am in beautiful Vienna, Austria here. Unfortunately, I can't be there in person this time, but I am really excited to be here. And if you want to follow me practically anywhere on the internet, I am at MXSTBR, basically everywhere. I am the co-founder of GraphCDN, which is the GraphQL CDN. If you are in the React community, in the React.js community, or in the JavaScript community more generally, you might have used some of the open source projects that I helped build, like Styled Components or React Boilerplate or Microanalytics or a whole bunch of others. I'm really active in that scene, and so if you're there, you might have used some of those projects as well. The story of GraphCDN and how we got there started in 2018. At the time, I was the CTO of another startup called Spectrum. And at Spectrum, we were building a modern take on the classic community forum. So essentially, we were trying to combine the best of what PHP BB gave us 20 years ago with the best of what Discord and Slack give us nowadays. That was essentially the idea. It was a public forum, but all of the comments on any posts were real-time chat. So we tried to take these two worlds that are currently very separate, where communities in Slack and Discord write lots of messages, but none of them are findable, and make them public and a little bit more organized so that you could find them afterwards on Google or elsewhere. And we tried to combine those two worlds together. Now, that actually worked out surprisingly well, which led to quite a bit of user growth. As you can imagine, with all of this user-generated content, lots of people found us on Google and elsewhere and started visiting Spectrum quite regularly. That meant we had quite a bit of growth. Now, unfortunately, I had chosen a database that wasn't very well supported. I had chosen RethinkDB, which nowadays doesn't even exist anymore. The company behind it shut down after a while. And I'd chosen that database originally because they advertised themselves as the real-time database. And their key feature, or the thing they praised externally, was that you could put this changes key at the end of any database query, and it would stream real-time updates to that database query to you. And so you could listen to changes to practically any data changes, which felt like a fantastic fit for what we were trying to do. Because obviously, almost anything in Spectrum was real time, right? The posts popped in real time. The chat was real time, of course. We had direct messages, which had to be real time. So this felt like a great fit for what we were trying to do. Lesson learned in hindsight: rely on the databases that everybody uses. There's a reason everybody uses Postgres and MySQL and now Mongo. There's a reason those databases are as prevalent as they are, and it's because they work. I'm a lot wiser now. I wasn't that wise back then. And so it very quickly turned out that RethinkDB, the real-time nature of it, didn't scale at all. We had hundreds of thousands of users every single month, but RethinkDB couldn't even handle 100 concurrent change listeners. Now, as you can imagine, every person that visits the website starts many different change listeners, right? We're listening to changes of the specific post that they're looking at. We're listening to changes of the community that the post is posted in. We're listening to new notifications. We had a bunch of listeners per user. And essentially, our database servers were on fire. Literally on fire. Well, thankfully not literally, but they were crashing quite frequently. I Googled servers on fire and found this amazing stock photo of servers on fire, which, if your data center looks like this, you have some really serious problems. Ours weren't quite as bad, but they were still pretty bad. So we had this database that didn't scale, and we had to work around that limitation. We wanted to switch to a more well-supported database. However, that's a lot of work. rewriting the hundreds of database queries we'd written and optimized up to that point, migrating all of that data without any downtime. That was just a whole project, and we wanted to get there eventually, but we needed a solution for us crashing literally every day right at this moment. As I was thinking about this, of course, I realized that caching, we had an ideal use case for caching because our API was really read heavy. Of course, it's public data. Lots of people read it, but not as many people write to it. And so actually we had an ideal use case for caching. We'd originally chosen GraphQL for our API because we had a lot of relational data. We were fetching a community, all the posts within that community, the authors of every post, the number of comments, a bunch of relational data. And GraphQL was a fantastic fit for that use case. It worked out extremely well for us, and we really enjoyed our experience of building our API with GraphQL. The one big downside that we ran into was that there weren't any pre-built solutions for caching GraphQL at the edge, which is what we wanted to do. Now, we wanted to essentially run code in many, many data centers all around the world, and we wanted to route our users to the nearest data center and cache their data very close to them for a very fast response time, but also so that we could reduce the load on our servers. Now, if you've ever used GraphQL, then you know that that is essentially what GraphQL clients do in the browser. If you've heard of Apollo Client, Relay, Urkel, all of these GraphQL clients, what they are is essentially a fetching mechanism for GraphQL queries that very intelligently caches them in the browser for a better user experience. So in my head, basically the question I wanted to answer was, can't I just run a GraphQL client at the edge? GraphQL clients do this in the browser. Why can't I just take this GraphQL client that's running on my local browser, put it on a server somewhere, and have that same caching logic, but at the edge? To answer that question, I want to dive a little bit into how GraphQL clients cache. If we look at this example of a GraphQL query, which fetches a blog post by a slug, and it fetches its ID, title, and the author, and of the author it fetches the ID, name, and avatar. And there is one magic trick that makes GraphQL caching really great, and that is the __ type name meta field. You can add that to any GraphQL object. In your query, you can add that to any object type, and you will get back the name of the type of the response. So, for example, with this query, we would add type name in these two places for the post and also for the author. When the origin responds with the data, the response will look something like this, with the important piece being that now we have the post data, and we know that the type that was returned there was a post. And the same thing for the author. We got the author data, and we also know that the author is a user. And when we take this response and we store it in our cache locally in the browser, we can now associate that cached query response with those two objects. We can tag it with post with the ID 5 and user with the ID 1. Okay, that's fine. So we've just taken this query response, we've put it in the cache, we key that by the query that we saw, so by the get post query. And anytime we see the same query, we return that same data. Why are these tags relevant? Why do I care that this contains the post with the ID 5 and the user with the ID 1? Well, this is where the magic comes in. GraphQL also has something called mutations, which are essentially just actions. Anything that changes data needs to be a mutation. For example, if we had a mutation that was called edit post, which edits a post. In this case, we're editing the post with the ID 5 and changing its title. Any mutation also has to fetch whatever it changed. So in this case, we're getting back the post. And again, we can do the same thing we did for the query and add the __ type name field to the response. Now, when that response comes back from the origin to our client, the client can look at this response and go, oh, look, we just sent a mutation to the origin. That mutation has come back from the origin, and the data that was returned was the post with the ID 5. Ha! I actually have a cached query response that contains that post with the ID 5, and I can now automatically invalidate that cached query result that contains the stale data of this post. That's amazing, right? And this is what GraphQL clients do under the hood. They do this magic invalidation based on the __ type name field and the ID field, and then they combine them to invalidate any stale data that has been changed at the origin. There's one slight edge case here where the magic kind of ends, which is list invalidation. If you imagine a query that fetches a list of blog posts, in this case just their ID and title, when we look at the response to this query, it's an array that just contains the one blog post that we have right now, the post with the ID 5, how to edge cache GraphQL APIs. Now, a mutation that creates a new post now poses an interesting problem because, of course, the response to this create post mutation will look something like this. It will return an object of a post with the ID 6. But, of course, our cached query result for the post list doesn't contain the post with the ID 6. And that's really annoying because that means that GraphQL clients can't automatically invalidate when new items are created. Kind of frustrating. Now, thankfully, they found a good workaround for this, which is manual invalidation. Essentially, GraphQL clients give you different APIs to manually influence the cache and change it depending on which things pass through it. So, for example, with Urkel, which is the third biggest GraphQL client, this would look a little bit like this. You could tell Urkel that when the create post mutation passes through the GraphQL client, invalidate any cached query result that contains the posts query, that contains the list of posts. And so that way we can automatically invalidate that, no problem. And whenever a post is created, our GraphQL client will automatically refetch the fresh data from the origin. GraphQL clients actually go one step further and they do something called normalized caching. If we go back to our original query of fetching a single blog post, its ID, title, and its author, then rather than taking the entire response of the post with the ID 5 and the user with the ID 1 and putting that entire thing keyed by the query into the cache, they actually take each object within the query response individually and store that individually. So inside of Urkel's cache, this looks a little bit like this, where we essentially in the cache store, okay, the post with the ID 5 corresponds to this data, and the user with the ID 1 corresponds to this other data. Why do we care to do this? Because now, if a query comes in that, for example, fetches the user with the ID 1, then the cache can go, oh, hold on, you're fetching the user with the ID 1. Although we haven't seen the specific query before, we do actually have that specific data in our cache, and we can just serve you that on the client without you having to go to the origin to fetch that data again, because we've already fetched it. It was just deeply nested in some other query, but we've normalized that for you and can now give you the user data for the user with the ID 1. No problem. Just like that. Which is very nice and actually makes for less network traffic and a much nicer user experience because things will resolve much, much faster since they're already on the client and loaded. Very nice. You essentially only ever fetch every object once, which is fantastic as people, particularly if people navigate around your app quite frequently. Now, the one thing that's missing here that you might have noticed is the post.author. We have the post with the ID 5 data and the user with the ID 1 data, but how do we know that the post author is the user with the ID 1? Well, Urkel stores that in a separate data structure that looks like this, which essentially just talks about the relations or the links between things. So here we're essentially saying, hey, if you're fetching the post with this specific slug, that corresponds to the post with the ID 5. If you're fetching the post with the ID 5's author, then that corresponds to the user with the ID 1. And then the user with the ID 1 doesn't have any further relations or links that you can go into. Now, what I really want you to take away from this section is that GraphQL is actually awesome for caching. It's actually really, really good for caching because of its introspectability. It tells you what data you're returning. And this introspectability combined with the strict schema where you have to return something that matches that schema means it's actually really good for caching. And that's also a lot of the reason why so much great tooling has spun up around GraphQL. It's gotten such wide community adoption that if one person builds tooling for it, because it's always the same GraphQL spec that it has to follow, everybody else gets to benefit from that tooling. And that's incredibly powerful. Now, to get back to my original question that I posed way back in 2018, can't I just run a GraphQL client at the edge? Can't I just take this logic that Apollo client, Relay, and Urkel have internally anyway. Take that same code and just put it on a bunch of servers around the world at the edge so that everybody that uses Spectrum everywhere gets super fast response times, and we get to reduce the load our server has to handle massively. Well, the key to the answer of this question lies in the last part, the edge. Because as it turns out, GraphQL clients are designed with very specific constraints that differ ever so slightly from the constraints we would have to work with at the edge. One of the main ones that we have to deal with if we were to deploy caching logic to the edge is authorization. Because, of course, if a GraphQL client runs in the browser, it knows that if something is in the cache, whoever's requesting this again can access it because it's the same person, right? If I'm using Spectrum and I'm querying for the post with the ID 5 and the GraphQL client puts that in the cache, then the GraphQL client doesn't have to worry about authorization. It doesn't even have to know anything about authorization because I am allowed to access the post with the ID 5. So if I request the same post again, the client can just give that to me from the cache, right? And go, yeah, of course, right? No problem. At the edge, that's slightly differently, right? If we have one server sitting that a lot of users are requesting data from, some of those might be allowed to access the post with the ID 5, but others maybe aren't, right? Or maybe even more specifically, if you think about user data, right? Maybe somebody's allowed to access their own email, but nobody else is. And so we can't just take a query and put that result in the cache because that would mean everyone gets served the same data. So if somebody queries some data that's sensitive, that's specific to that user, suddenly that will be served to everyone. That would be a nightmare, right? That would be a terrible security nightmare and a really bad experience because we would essentially just be leaking data. Very bad idea. So at the edge, what we have to do is, rather than just making the cache key a hash of the query, so essentially we take the query text that we have in the variables and we use that as a cache key, rather than doing just that, we also have to take the authorization token into account. Whether that's sent via the authorization header or whether that is a cookie, we have to just add that to the cache key so that if somebody else sends the same query, they don't get the same response. It's as simple as that. Just put the authorization token in the cache key, and everything will be fine. The other part that's a little bit different is cache purging, because not only do we have to do automatic cache purging and support manual invalidation for list invalidation, we also have to do it globally, right? If you're running at the edge in all of these data centers globally, then you have to invalidate that data globally, right? If the post with the ID 5 changes and the user sends a mutation to edit that, or the server says, hey, look, this has changed and wants to manually invalidate it, then you have to do it globally. You can't just do it in one data center. That would be a terrible experience because the stale data would stick around in every other data center. You have to do it globally. And so as we were thinking about these problems for GraphCDN, as we were building out this GraphQL edge cache solution, we came to the conclusion that we're going to use Fastly's Compute at Edge product. Now, we are huge fans of Fastly here. And the reason we chose Fastly is because, like their name suggests, they are super fast. Fastly has about 60 and ever-increasing data centers worldwide spread across the entire globe. Now, here is a crazy fact. Fastly's invalidation logic, right? If you take a query response and you put it into Fastly's cache and you tag it with the post with the ID 5, if you then send an API request to Fastly to invalidate any cache query result that contains the post with the ID 5, they can invalidate stale data within 150 milliseconds globally. 150 milliseconds globally. That is probably faster than you can blink, right? In the time that it takes me to do this, Fastly's already invalidated the data globally. That is absolutely mind-blowing to me, right? And I actually looked up a while ago. I was like, wait, hold on. How fast even is the speed of light, right? Surely that takes a while to go around the globe once. And so I looked it up, and actually light does take 133 milliseconds, if I remember correctly, to get across the entire globe. So how can Fastly invalidate within 150 milliseconds? That is super fast. Well, the answer is, of course, that they don't have to go around the entire globe because they're going bi-directional. They're going both ways at the same time. So they only have to go around half the globe, which cuts the time in half. And then, of course, they also they have a really fancy gossiping algorithm, which you can Google. They've written some great articles about it, and I bow down in front of their engineers because it's absolutely genius. And it is so fast that it enables our customers now to cache a lot more data, right? If you can invalidate stale data within 150 milliseconds globally, imagine how much more data you can cache, because it will never be stale, right? When the data changes, send an API request, and 150 milliseconds later, everybody globally has the fresh data. Imagine how much more data you can cache if you have the super fast invalidation. And that's the reason we use Fastly. They're super fast, and we're super happy with them. So that's essentially what GraphCDN is. We rebuilt this caching logic to run at the edge, to take authorization into account, and to have this global cache purging. And we deploy it to Fastly's computed edge 60 worldwide data centers to allow our customers to cache their GraphQL queries and their GraphQL responses at the edge. I wish this would have existed back in 2018 when we had our scaling problems with Spectrum. At the time, I just built a terrible in-memory caching solution that reduced the load slightly until we eventually got acquired by GitHub. And if we had GraphCDN, we would have been able to scale so much more smoothly. We would have saved so much money because, of course, running something at the edge is much cheaper than running the request through our entire infrastructure. And it would have been a much better experience for all of our global user base because everybody would have had super fast response times from their local data center. All right. I hope you learned about GraphQL caching today. The main thing I want you to take away is GraphQL is amazing for caching. That's really the takeaway I want to hone in on. GraphQL, absolutely fantastic for caching. The introspectability, the strict schema, chef kiss. Just absolutely fantastic. And if you have a GraphQL API, I'd love to meet you. I'd love to hear what else we can do for you in the future, even if you don't need caching. Thank you for having me. If you have any questions, feel free to hit me up anytime. I am at MXSDBR, practically everywhere on the internet, and I look forward to hearing from you.